Welcome back, students. So today we will be discussing the topic of three-phase systems. We all know that three-phase systems are having many advantages more than the single-phase system. So we should first know that how the output is generated in a single-phase system, and then we will be discussing about the advantages of them. So basically you all are familiar with your this basic diagram. What is there is a magnetic field having two magnets north and south. Then there is a coil that rotates in this magnetic field. This is the magnetic field. This is the coil that will rotate. Now because of this magnetic field and the rotation of your this coil, what will happen? A current will start flowing in your this circuit, from where we can take the output from this resistance. Same type of construction can be made by keeping your this coil as fixed here as a stator winding and taking your this north and south magnet as the rotor of the system. So when the magnetic field moves in a stationary coil, then again a EMF is generated given by E equals to E sine omega t. Now let's see that how your this EMF is generated. So now I have taken the value of this omega t equals to theta. So I have taken different angles because by which the angular velocity of that coil is there. So I have taken different angles, 0 degree and corresponding sine theta values of it, and I have taken that in my this equation. So this is going to give me the magnitude of the voltage I am going to get at every instant. So now I am just going to draw it here. So you all can see that at 0 degrees you have got 0. At 45 degrees you have got the magnitude of 0.707. At 90 degree it is 1. Similarly at 135 degrees it is 0.707. Then at 80 degrees 180 degree it is 0. Similarly now in the negative direction this is minus 0.707 and let's say this is 1. So here we come here at minus 0.707 and here it is 1. And again here minus 0.707 and finally at 0. So now I am going to match all these points, and what I am going to get is a very familiar wave that we all say the AC output. So this is how a single phase system works, and now we will be starting with our three-phase system. So the main thing in three-phase system is that the output generated is differentiated by an angle of 120 degree from each other. This is given by the formula 360 degree by n. If there are two phases, then 360 degree by 2, three phases 360 by n. So n stands for the number of phases we have. So this is the phasor diagram of the output voltages. This is our reference that we always take as R, then Y, then B. So they all differ by 120 degree angle each. And this is basically the construction that how we get our three-phase system. If you all remember the single phase I just drawn, there was only single coil R and R dash. In between there was a magnetic field. So here what is happening is we have got three coils R R dash, Y Y dash, B B dash. Basically R R dash stands for start and end point of the same coil. B and B dash start and end point of the same coil. Y and Y dash start and end coil of the same coil. So this is our system that is now going to, now when the magnet is going to come here, your this coil is going to give you 1 voltage that we just discussed how the output is formed by E equals to E sine omega t. Similarly by an angle of 120 degree this is going to generate the output. By an angle of 120 degree this is going to generate the output. So this is how we get our output from a three-phase system. As we just discussed that there are two ends of 2 points of a coil. So let's say this is the start end and this is the end. This is start, this is end, this is start, this is end. So if we are going to attach the similar ends of the same coil, then what we are going to get is a star connection of a three-phase system. So because this is three-phase, so that means three coils will always be there. So we will be always talking about the three coils in the system. But how they are connected gives the delta or star connection system of the three-phase. So now here we come on to the second type, where the end dissimilar end comes with the start one. Dissimilar start, dissimilar means dissimilar ends are connected together. So such type of system provides us with a delta system. Now we come on to the advantages of three-phase system. The very first advantage is the less conductor material being used in the three-phase system. Now the question comes how. So if you are going to check that we want a three-phase system using single-phase systems, just check out the material that we are going to use. There will be 2 conductor wires for each phase, so there will be a total of 6 conductor wires. But same if we want a three-phase system from a designed three-phase system, what we can see here is that either it is a three-phase system star or a delta, we are going to get 3 wires from it. So 3 conductor wires are required for a three-phase system when we are using from a three-phase system. So almost half the conductor material is required here. Second point we come on to that the output generated here is always pulsating. You can see there is a lot of difference between the two peaks, but when we check for the three-phase system, it is almost constant. So because of this, the torque produced by the three-phase systems is constant, whereas the torque produced by the single phase is pulsating. So rest of the advantages are the output produced by the three-phase machines is more as compared to the single-phase machines. Single-phase motors are self-starting, three-phase motors are self-starting while single-phase are not. The torque produced is more and uniform in case of three-phase, while the torque is less and pulsating for the same power of the two machines. So now we come on to the difference between star and delta system. So if you just see here, we already discussed that similar ends are joined to get a star configuration, while dissimilar ends are joined to get a delta configuration. In a star connection, line voltage is always equals to root 3 of phase voltage, while in case of delta, line voltage is equal to the phase voltage, and these 2 points are very much going to be used in the numericals that we are going to discuss further. Then the line current is equal to phase current here, and the line current is equal to under root 3 of phase current here. So this is our three-phase, and three-phase 4-wire arrangement can be obtained from a star connection, but only a single arrangement, that is three-phase 3-wire, can be achieved from a delta connection. Because of the presence of neutral wire and making it earth, it provides the safety of all the systems joined there, but because of no neutral point present in the delta system, it is used for the low voltage systems.